Hello everyone, in this video we will talk about calibration of 8.5 digit multimeter and calibration club intercomparison concept initiated by members on EV blog forum in metrology section. Calibration club concept based on idea of small travel kit with known good standards. Such kit can be shipped and provided to members interested in comparing their instruments such as DMMs, analyzers, and in-house DC and resistance voltage standards. Here you can see simple block diagram that shows organizing lab in a center who is responsible for the kit and 8 participant members with their labs. Kit is shipped between every lab and people do their measurements, providing results to pivot lab publicly. And as a result, all 9 members can compare their data and determine quality of their lab measurements capabilities. So as you can see on EV blog forum, round 2 started around 2018 and finished in November 22. There are a lot of information on the forum, so be sure to check it out. And Randall, who is a key member for round 3, reached out to XDevs to request for calibration on 10-volt reference in a travel kit. This video provides overview on results for this calibration and also complements article published on xdevs.com. An article called Calibration Tests for Round 3 USA CalClub and publicly available now. I've also decided to go one step further and offered free calibration for Randall's DMM 8.5 digit Keithley model 2002 to help with his effort for public metrology. In the beginning of the article, I give introduction to this CalClub concept and show a calibration kit I received. So here is the Keithley 2002 with the DC reference called XDevs FX. So it has the cable that comes with the reference, and meter didn't come with any other cables. So this instrument was bought originally by Randall used, and it was spot checked and calibrated at few ranges, but we will see how it goes for everything else. So the self-test passed without any problems. And we can continue to check the firmware. So here is the information with the serial number. It has memory option 2 and the latest firmware is A10. There will be no disassembly for this instrument and no firmware upgrades. As we can see here, last adjustment was performed in year 2005 in August. So this instrument is overdue for the fresh adjustment for many years. Feel free to use data and results from this article or video, but if you do so, don't be evil and give links to source here at xdevs.com. Table 1 here lists equipment used to perform as received condition calibration for Keithley 2002. And main tool here is Fluke 5720A calibrator, which was tested and calibrated against reference HP3458A, resistance standards and resistance bridges from Measurements International. Voltage AC range used Fluke 5725A for higher frequency tests. And photo below shows the measurement setup as it was tested, and ambient temperature in the lab was kept at 23 degrees centigrade within a couple degrees. Model 2002 multimeter was allowed to warm up for at least a day, and all the tests started in middle of November. And calibration procedures were inspired from Model 2002 calibration manual, revision D, May 2004, and specification manual, revision I, November 2009. All tests were automated as much as possible to reduce risk of human errors and save time during testing. All points are verified against 24-hour specifications and not typical 1-year interval specifications. AC voltage and AC current functions were tested against 90-day specs, since no 24-hour interval is available from Keithley for Model 2002. And first test is DC voltage 0 offset. Low thermal copper short was plugged into DMM jacks and all ranges were verified. No issues here with DC zero offset. Meter met all specifications with worst error around 9% on the most sensitive 200 millivolt range. Now we can move on to DC gain verification. This is the first test that shows points barely meeting 24-hour spec, such as negative section of 2 volt range and tightest spec 10 volt points on 20 volt range. Randall did adjust this meter DC voltage function using point cal function, so this explains why it is looking not too bad for calibration that is overdue by 18 years. Negative 100 volt and 1 kilovolt range is also a little bit too tight to the edge, but again we are testing against 24-hour specs, not 1 year specs. Next test is 4-wire resistance measurement functionality. First we check zero offset on both 4-wire functionality and 2-wire for resistance ranges. Resistance zero offset verification gave us pretty good results with bit higher deviation on 20 ohm, 200 ohm and 2 kilo ohm shorts with 2-wire mode. All these tests were done with the low thermal 4-wire short at the meter's input terminals. Now the next step is verify all resistance functionality with the gain errors on each range. This is done with Fluke 5720A calibrator configured to source 17 fixed resistances from 1 ohm to 100 mega ohm. 1 gigaohm was not tested here because 5720 cannot source resistances this high. And here we have solid failures for everything above 200 ohm range. So 20 mega ohm range is barely meeting requirements. And interesting to note that 100 mega ohm is easily passing specifications since it's quite wide tolerance at 152 ppm. 1 gigaohm range is not tested here because it cannot be sourced directly from 5728 calibrator. All these points were collected over multiple samples with proper settling times. Green block here lists data sent to GPIB bus between calibrator and DMM. Initial readings were discarded until stable conditions were reached. Next test is AC voltage, and there were no surprises there. Everything passed with wide tolerances, so no problems. Next is DC current, and here we have 20 milliamp and 200 milliamp failing specs again, as well as 2 amp is barely meeting the 24-hour spec. So the next is AC current, and AC current is pretty wide in tolerance, so no problems to pass all the ranges and specs. At this point, we completed initial calibration of DMM for as received condition. Next, we can go ahead with in-depth tests and perform adjustment on this DMM. And first test to do is a study on temperature stability of this Keithley 2002. Large Peltier thermal chamber was built to do tests like this. Air inside temperature chamber can be programmed and precisely controlled with the help of 6 80-watt Peltier elements and programmable controller. Chamber can provide stable temperatures from +10 to +50 degrees centigrade, but we will be testing only range from +18 to +28. Test DMM was placed inside of this chamber, and 44-hour-long very slow temperature sweep was programmed to execute. Results for these tests for all DC voltage, DC current and resistance function ranges were presented in article table 9. Best thermal stability is achieved on 2 volt range with temp code just minus 0.1 ppm per degree, followed by higher voltage ranges at minus 0.25 ppm per degree. And at this point we can do the full adjustment for this instrument using the calibrator, And in table 11, you can see commands used to send for calibrator and DMM during the adjustment procedure protocol. These adjustments was done on January 13, 2023 with a freshly adjusted and tested calibrator. To start calibration, need to poke a hidden button Cal under the input switch, and this will allow instrument to accept calibration constants after the fresh adjustment procedure. So next we need to connect 4-wire terminal short and perform the calibration for 0. And after this, we will need to connect 2-wire terminals from calibrator to start with DC voltage adjustment. So the first point is 2 volts, followed by 20 volts, and so on. To save time, this video is actually faster than real time. The whole procedure in real life takes about 15 minutes or so. And when instrument is calibrated using remote control from GPIB, it does not show display readings. So you will have to navigate through different calibration steps using the procedure coded in a host computer. Now after 20 volt calibration point, there will be number of resistance ranges to be verified. So for this 4-wire connection between calibrator and DMM is required. And this is what I'll do in background here. In each calibration step, there usually takes about 30 to 40 seconds. So here you see me messing with cables to plug everything for the next step. And then during the calibration, we need to enter actual value from the calibrator, not the nominal value. So in this case, I'll need to enter 0.9999824 mega ohms for calibration value. And the same goes for all the other ranges that instrument requests. So we go through resistance down to 19 ohms and then followed by DC current points. And for DC currents connection, we need to use wide DMM jack for current input. So here at the final 19 ohm point, we can switch the terminals, connect auxiliary current output on the calibrator side, and also switch the terminal on the DMM side to allow current to flow into the DMM. After this is done, we can continue with the test, and first point is 200 microamps, then 2 milliamps, 20 milliamps, and 200 milliamps, and final point is 1 or 2 amps. Please note that higher current at 1 or 2 amps require quite a significant time to allow self-heating inside of the DMM to reach the stable point. In this 20 times faster than real-time video, you can see the self-heating with 2 amps applied to DMM, showing its effect. So the reading would either drop or increase, depends on the temperature coefficient of the current shunt inside 2002. Now that adjustment is completed, we can repeat the same calibration performance verification tests and go through all the functions and ranges to make sure everything is good and happy. And we should expect to meet 24-hour specifications with good margins. Because we used a freshly characterized calibrator, and there should be no problems to meet specifications within 24-hour specs of Keithley 2002. And indeed we can see all good solid green points for DC voltage function. I've shown additional snapshots from specifications with the tested points marked in blue, just for a better indication. And here we have resistance function ranges, all good, within less than 21% of allowed deviation. And 1 gigaohm is also tested against a fixed standard. So we have no problems with the AC voltage function, and DC current is all green as well. It's important to note demanding 1 amp and 2 amp DC current test points, which are affected by long self-heating of the current shunt in model 2002. I've tested both of my own Keithley 2002s to verify this behavior, and it is indeed very similar. So calibration procedure for the 2 amp range was improved as a result, allowing additional 20 minutes for DMM shunt to reach stable condition. We don't have this problem for AC current, so at this point we have completed adjustment and calibration of Keithley 2002. Next step is to test INL and move on to next items in our calibration kit. Nonlinearity is verified against reference 3458A, and I used the same 5720 as a source, connected to both DUT 2002 and 2 of 3458As. All instruments were controlled by Raspberry Pi, and data was analyzed by Python library NumPy. And here is the look on the setup. So you can see reference 3458As and DMM on top right corner, together with the test 2002 in this particular verification. And here is the speed up screen capture of application that collects data points with 1% steps for particular range on both 3458A used as a reference and DUT instrument, in this case Keithley 2002. I will not focus on INL results too much in this video, but all the data is available in article, so be sure to check it out. I'll just outline that 10 volt range is indeed very good and meeting Keithley specifications at 0.2 ppm INL, and from 10 volt to plus 10 volts it's actually meeting even better specs to plus minus 0.1 ppm, just like 3458A. And also higher 200 volt range was also tested. Now next star of the USA CalClub kit is FX reference that I donated back some years ago. This is how module looks like together with manual. It requires bipolar power supply or a battery source to operate. And here are some old results from original calibration in May 2019, as well as follow-up calibration in January 2021. And this is the current data as soon as I received the reference in November 2022. You can see USA CalClub FX reference added from November 17. And here is also a graph with a 41-day log. Huge drifty line from top left to bottom right is a new reference based on ADR1000 chip. So we can see that new reference is indeed quite drifty and require a lot of time to settle. And here is the final plot over 64 days collected on USA CalClub FX reference with a vertical span plus minus 0.4 ppm. And of course I tested temperature coefficient of reference to make sure it's still good and happy. So this is the 15 January 2023 calibration with the alpha minus 0.024 ppm per degree. And this is estimated drift of that travel kit reference. So it's pretty impressive, but we need definitely more data points to have a better estimation. Now you might ask, how can I ensure low uncertainty of all these DC voltage measurements? And the answer is presented below. Essentially, we used in-house FX reference and monitor it over 5 years time as well as other commercial standards such as DATRON 4910 or Flux 732A. DATRON 4910 was calibrated with a quantum voltage standard using direct measurement, actually 2 times, and by using this data we could estimate long-term drift of in-house zener standards, and that allowed low uncertainty for DC voltage measurements presented in this video and article. And the next item is 10 kilo ohm standard that I donated to USA CalClub. I will not focus too much on it in this video. You can find all the information and details in article. Here is traceability map with the used references and calibration chain to primary labs. All these measurements were performed with 9.5 digit resistance bridges from Measurements International. And the final traceability map for all the measurements performed in this article and video shown on this image in the summary. As a result, performance of USA FX zener reference was confirmed good, and I'm looking forward to see what members will do with it on round 3. Keithley 2002, USA Club FX, and newly donated Leeds & Northrop 4040B 10 kilo ohm standard were packaged and shipped for organizer Randall using UPS air shipment on January 16, 2023. On this note, calibration is all concluded, and all these activities were performed free of any charges or payments, since XDev's.com project is to share the metrology passion and demonstrate importance of good quality measurements and not any business interest. Hopefully this publication and video will inspire a new generation of engineers and metrologists to join this very interesting and often challenging industry. I would also like to thank my friends and metrology community in general for making stuff like this possible, and as well as heroes that supported XDev's project over last decade to share the passion of engineering, physics, and educational design research. Thank you all, and I hope to get your feedback soon.